Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right. Well, welcome everyone. So today we have with us Anna McDonald, who works for Confluent, right?
That's correct.
Okay. And I don't think we've ever met in person, so this is fun to get to do this virtually, like the virtual meeting. But at some point, hopefully we do like actually intersect on the physical plane of reality and get to like have some sherry together or something.
Absolutely.
So.
That's why I was telling you about Blast from the Past.
Because
that's right. She drank sherry secretly.
Oh, she was in the bomb shelter and had to hide the sherry.
Secretly drinking sherry because she was going crazy in the fallout shelter.
I drink sherry in the open, right? Yeah. I'm very transparent about my sherry intake. Yes.
Okay, yes.
It'd be hard to hide drinking sherry from somebody if you're stuck in a bomb shelter with them.
Not a lot of options.
Yes.
Yeah.
So I'm going to, not play. I'm going to actually be the ignorant one and say, what's Kubernetes? What is it?
No, not Kubernetes. Kafka.
Kafka. See, I didn't even know what the right thing was. Okay, what does Kafka do? What is it?
So when you talk about Apache Kafka, like at its heart, it's a durable log. I'm not a fan of anything like in life or really, in technology that's transient as much. And so I was never a fan of any messaging systems. They were a waste of time. And I'll say that out loud until I met Kafka. And I would, Kafka operates in a way that's unlike any of your, more traditional pub subs. And so in my heart, that's what it is, right? For Apache Kafka. And it allows you to have and maintain a system of record that doesn't lend itself to duplication, like a broadcast pattern. If you have multiple consumers, right, the data's still there. And just the protocol of it is elegant. The ecosystem around it too is amazing. And Kafka Streams, which is kind of the streaming library that is part of the Apache Kafka ecosystem, is part of that. It's the love of my life.
Isn't that now called KSQL DB?
No, those are two different things.
No, two separate things. Okay, so there's Kafka Streams and KSQL DB.
Does it do something like, I don't know, say RabbitMQ does? I mean, is it when you say messaging system, it's like almost like the original object-oriented programming, sending messages and somebody handling the messages?
Yeah, I mean, it could, but I think that would be underwhelming, like when you look at Kafka. And the reason is because when I see somebody, and what in my job, right, I work with our customers and to set, best practices, a lot of times, giving them, the best practices for eventing, event patterns. How do we move to, near real-time streaming and the like. And one of the things that you find very quickly is that because Kafka is a durable log, because it was built to handle the volume of information, all of a sudden, if anyone approaches Kafka and says, I need to do pub sub, they get very frustrated very quickly. And I'm like, well, no, do you really need to do just pub sub? Because if so, you can use Kafka, but you can do so much more with it, right? Because
isn't pub sub these days just an anti-pattern? Like, does anybody really have an actual valid use case for pub sub?
Okay, so when I think pub sub, what I think is there's a lot more intelligence, right, on that broker side with knowing what the state of a message is. It has to know whether you've got it yet, so it knows if it needs to remove it, right? And so there are cases, and I've met with customers before, and I'm the first person to say don't use Kafka for this. So, if you need something like NAC per message, right? No. Like Kafka's not going to do that for you because Kafka's ignorant. You're the one who has to tell it when you've received those messages and when it's ready to move on, right? We do that via offsets. So it's basically a poll, right? I get a batch of messages and then I decide whether or not I want to acknowledge that batch by updating my offset. As you might imagine, trying to like shoehorn something like NAC per message in that ecosystem, it's not a natural fit. So I would say,
what's like a good like business use case for NAC that you couldn't do with like offset tracking, like offset,
like so you got to think about
external
it like
offset storage,
separation of regulatory regulatory operations. So for example, if I'm somebody and I've fronted whatever my messaging system is with an API, and whatever's feeding those messages is not allowed to write. It cannot update. It cannot change anything. It can just pass through those messages, right? Whether or not what the state of reception is has to be held with the broker in that case, or somewhere else that's admitted. So that's what I've run into, right?
Yeah. And so in that case, you would say like Kafka is not your jam if that's what you
Yeah.
need.
Now Confluent might be your jam with like, a pretty
Right.
interface that we develop and sell to you, right? For stonks.
Right.
But when we just, talk about, AK, right? Like, and that's the thing. So when I always say this, right? If Confluent's business prop was to be the best fully managed Kafka distribution, that would not make me happy as a employee or as a stockholder. So I always try to separate that because I do a lot of talks about Apache Kafka. And so what Confluent offers is Kafka as its heart, but then a crap ton of other amazingly valuable features as well. So we might offer something, right? Like something, that would do and would accommodate NAC per message on top of Kafka, right? But if you're just somebody who's listening to this and you're like, I want to use Apache Kafka, I have, this huge regulatory separation of concerns and I need to do NAC per message, Kafka's not going to hold that for you.
So let's talk about a place where...
name
Kafka, the name.
The philosopher, I assume, is who they named it
after.
Yeah,
I think Jay, who's our CEO, read a lot of Kafka and he was like, it's easy to spell, which I appreciate because I'm a horrible speller, and like went with it.
Nothing deeper
no
than
exciting
that.
story
I don't
there.
think so. I mean, I could be wrong. I'm sure people will tell me if I'm wrong, but I think that from the long and short of it, I think that's what went down.
Okay.
In the history, I don't know if you know, Bruce, but it was actually built at LinkedIn it started as a project within LinkedIn for dealing with the problems that LinkedIn had technically, and then they open sourced it with Apache.
Yeah. And then Jay took it, and Jay and Neha and June, who is just a beautiful person inside and out. June's like one of the nicest people I've ever met in my life. And then they founded Confluent. Yeah.
Nice.
And I guess, maybe James was getting to this. What kind of use case would you see for this?
Oh my gosh, that's why I never get bored. So like every
all data that isn't NAC messaging.
It's fantastic.
Wait, what's NAC messaging?
So that's like I'm getting a bunch of messages, right? And maybe I receive some of them, but in a non-blocking fashion, somebody has to keep track of the ones I haven't acted yet. And that person can't be me. And that,
in a typical like messaging architecture, you may need to track if a message has been processed by the receiver. And so one pattern to do that is to say, all right, the receiver needs to acknowledge back to the thing that sent the message that it has been received.
Right. So we're talking ACK, NAC kind of things. I'm still having a hard time imagining like what do I need this thing for and how am I using it? And, really basic stuff.
So one of the things that, like, again, I like about my job is I get to learn so much about industry. So if you take something like fintech, financial services, we have people who run an entire, retail bank on Kafka. Fraud use cases are kind of bread and butter for us, right? So you've got, East Coast, West Coast, somebody swipes a card, right? Is that fraud? We have one customer and their goal is to make sure they detect it before your credit card's back in your pocket. Right. And Kafka, because it was made to handle such a volume, being developed at LinkedIn, right? It's all those interactions on a website, is uniquely suited to do that. The other ones, I mean, there's some really, so for example, and there are obviously customers I can talk about and ones that I can't, legally. And one of the presentations in one of my customers is the CDC, the Center for Disease Control. So when COVID hit, Kafka is used and Confluent Platform is used for, COVID testing data and vaccination data, which, as you might imagine, made me feel a lot better helping that initiative during the pandemic because I felt like I was actually doing something. So you've got, all of this information coming in from all over the country, right? It's used to help identify hotspots. And because you can stream it in so fast, because once it gets there, you can do those transformations with something like Kafka Streams very easily, and then spoke it out to whatever sync you want. It just is a very elegant way to do, those types of use cases.
Okay. Maybe I'm asking the question wrong. What problem does it solve? Where do I get where I go, oh, I need a thing like this and Kafka is a thing like this? What's
so let's say that, you're a normal company and you have like a crap ton of legacy databases, right? And you really want to do eventing because that's a lot better way to do. You've got a lot of people and the easiest one to say, let's say that you're doing customer data and somebody goes on your website and they change their address.
Wait, why do you want to do eventing?
Well, because if you wait 24 hours, like your competitors have already beat you. So like,
Okay,
So
so
okay, so
things. Yeah, go ahead.
one way to look at this is that we have a traditional way of looking at data as a table, and it's just this like thing that you update and can query. But if you take a step back from that perspective, all data is just events that can flow as a stream. And what Kafka does is it shifts the paradigm from thinking about this table that is just a view of all the changes that have happened. Instead, let's look at data as a stream. And then we can do all sorts of interesting things when we look at it as a stream. We
Kind of
can,
more functional way of thinking about it, maybe.
yeah,
yep,
that's why I
that's right.
like it, because I have a functional brain.
Mm-hmm.
So Kafka is just keeping this log of all the events. And if you want something like a table, well, you can keep track of all the events and view it as a table. Or if you don't care about ever viewing it as a table, you just want to like send events to a bunch of different consumers, or a bunch of consumers are consuming events, then you can do that. But here's one of the really cool things with Kafka is that in a traditional like message streaming system, you think about things as like a given consumer, and so a consumer is gonna connect, begin consuming messages, and so you can do a stream oriented system. But what happens when you want to add like a second system? So back to your like CDC use case is like, I would guess that when COVID happened, all of a sudden they're like, oh, we need to do something different with all this
Absolutely.
data, with this whole data stream. And so then they connect another consumer and another consumer and another consumer.
Mm-hmm.
Well, those consumers get to decide, do I want to start at the beginning of all the messages in time, or do I want to start somewhere in the middle, or at the newest message, and am I okay with that? But it's pretty cool that now in the stream-oriented system, the consumer gets to decide where it wants to start from.
So that makes me think kind of like the actor model. You know, the
Mhm.
actor model gets events and it decides which ones and what order it's going to deal with them,
Yeah,
or whether it deals with them at all.
yeah, absolutely. And
But
yeah,
this, instead of having the queue in each actor, this is some sort of a centralized
exactly.
queue of
And that's the thing. I
events.
hate
Okay.
duplication of effort. It's annoying to me,
Mm-hmm.
right? And that's kind of what I talked about
Mm-hmm.
before with those normal messaging systems where you'd have to do like a broadcast. You have to set up something for each and every single person, right? When you have across an organization, to go back to that, there are tons of people who are interested when a customer's address changes, right? You create a stream of
Mm-hmm.
events. You can, and that's what I love CDC. I'm biased because I think it's awesome, and I think it enables people to get going quick. But all you do is you hook up change data capture from your database, and then every time an address changes, that is going to be published to Kafka, right? And anyone who cares can consume it.
And so, and you're also saying that every event is held forever.
So it can be, sure, yeah,
It can
absolutely.
be if you want.
Yeah, it's
Okay.
configurable. Yeah.
If that's important to you. Okay, so that way, if say somebody's dealing with data flowing in, they can choose to take this week's data, or they can choose data from the beginning of whenever you started collecting it. Okay, I could certainly see that as being useful for scientists, for example.
Yeah.
Mm-hmm.
Yeah, I think for me, Kafka opened up a whole new way to think about data. And I think I've ranted about this before, but small rant. I think it's absolutely horrible that the kind of default way that we deal with data in web applications, mobile applications, whatever, is that you load a page and the page doesn't change generally until you like hit refresh, even if the underlying data is changing. And this is one of those things where I'm like, this is just not the way that the world should work. And the reason why it works that way is because we've got database tables and we have a web page that does a query to that database table. We're not generally looking at data as being a stream. And so this leads to just, I think, generally horrible experiences where it's like, oh, geez, like that data actually did change and I didn't see the change because I didn't hit reload.
Yeah.
Well, I think we were constrained by the old client-server model, which was because of resources at the time.
And that's
Yeah.
true. And
It's like-
right. So I'll never forget what our DBA said to me when I first hooked this up. He was like, "Where's it going? Where is Kafka keeping all this? How is it not falling over? And I was like, that's the magic, my friend. Because, the way that Kafka was designed was to handle immense volumes of data. So one of the things we did with CDC was I had to figure out, and this is kind of what led me to Kafka, like in about 2017, was I had to figure out, okay, we've got these tables. They got, over 5-6 million records, multiple of them. We truncate them every night. I got to find a system that can take that truncation, right? And CDC and not bat an eye. And Kafka doesn't bat an eye. You can pump so much data into it that all of a sudden things that you could, like just what you said, things that you were constrained on before, were like, you're never going to be able to drive that much data out of a database to a messaging system. It's going to fall over. All of a sudden with Kafka, it doesn't bat an eye, and you have all of your events. The first talk I ever did was called Finding the Events Hidden in Your Database. And you have, it just opens up a whole new world of information that used to be locked in a database.
What was it?
Yeah, I mean, you lose, I guess, like a database table is intentionally lossy, right? It's compression. It is compressing all these events down into a view, and probably to Bruce's point, doing that for efficiency, because back in the day, we didn't have the space to keep around all the events that led us to that state. And now we generally do have the available data to keep all the events.
Mm-hmm. Well, and I was also thinking of, I mean, the client server thing was, it's like, okay, well, where are the powerful resources located? And so, it's mostly on the client and mostly on the server, and the client was this dumb thing, and, the bandwidth between them was limited and everything. So we designed around those constraints, and now we're still stuck with them. So we had to add that, what is it? The built-in push to JavaScript only happened a few years ago.
Yeah, server-side events and WebSockets. And
WebSockets.
And that's kind of what I was going to say. So like when we talk about the Kafka ecosystem, my favorite use case for KSQLDB is server-side filtering. So you can take KSQLDB, you can make a query like we talked about, like a table, let's say, that's indexed on stock symbol. We'll just for sakes and purposes, right? And there'll be a real-time stream that's updating, that K table, that cache for extensive purpose, RocksDB under the covers in real time. With KSQLDB, you can do pull and push queries. And those push queries it's a long-lived connection. So that for a dashboard use case, right, is very powerful. So then, you can say, hey, I only want to get this stock symbol. And then it's a continually updating data stream that's connected. And we have, native Java clients, we have REST clients, we have all kinds of things that you can hook into that. So it's really flexible that way.
So you talk about how rock solid it is. So I'm curious how they achieved this. Like, for example, what programming language did they use to build Kafka?
So Kafka was written in what I like to call Java Scala.
Java Scala. That's a good way to put it.
Right. And then as they built out the ecosystem, it's in Java.
Okay.
Yeah. So they initially built it as in Scala, but written by like traditionally Java developers. So it was Scala written like what we call like Java without semicolons.
Mm-hmm.
But but I will say, I laugh, but I will say that when you go and you look at the source code, my favorite class in all of Kafka is partition.scala. It's the one that controls like who owns what, right? Who's in sync. And for a distributed system, as you might imagine, that's kind of critical, like really important. It's incredibly elegant. Just the way that they've made those hard choices to be elegant and to build something that is part of the reason why I fell in love with Kafka. Before I went all in, I went and I looked at, obviously I always look at the code. And I went and I looked and I said, well, that's the way I would have done it. Well, that's smart. That's the way I would. And it just kind of made me fall in love with it.
Nice. That's cool. They got the foundational pieces done well. One thing I wanted to point out back to you real quick, the compression. I'm just going to harp on this a little bit longer. When you have a database, a traditional database that is essentially that like compression of all the events, you've lost all the events. Yeah. And I think that this is really important, is that when you start with a durable stream oriented construct, you can build everything you need on top of that. Whereas when all you have is a database table, you have lost your events, and there's all sorts of things you cannot build on top of that. anything, you've lost the stream of events, right? And so that's where I just love Kafka, because I'm like, it gives you the flexibility to do whatever you would need with that data.
And it gives you the full picture, right? That's what I love. I don't want half the story, right? I want the whole story. And I love the way Kafka does that, and CDC data, I know I'm going to say it again. I just love it. The struct is normally for all of our CDC connectors, be it, Debezium. I think, Confluent has an Oracle one, Oracle has Golden Gate. You can have the option of getting the before and after, right? And that is a money pattern. So until you can get, if that's all you've got, you can really use that to derive events, which is also like a derivative event pattern. It's just so powerful to be able to see the change and see what happened. And then again, like you said, you can take that anywhere.
Yeah.
So when you say you lose the events, I mean, you could store all the information about the events in your database, right?
Your DBA would kill you, but yes.
Okay. But
Yeah.
and then you're saying somehow Kafka can do this in an efficient enough fashion,
very
or does
efficient
it
way.
use a different database, or do you?
So the actual logs are written. You tell us, because I just read something once, but
right. So it's a durable log, and when I say that, I mean it's a log. It's just a .log file, right? And that data is stored, and obviously, we've made improvements. So the batch, those records batches are stored compressed with whatever compression type you want to select. As a producer, you can also set it at a broker side. I hardly ever recommend that unless you have serious issues, because then, the broker is responsible for compression, shoots up your CPU, yada, yada. But it stores it as a compressed log file in segments. And so if you were to go look at a file system on Kafka, you would see log files for that partition. So then, the question that we've had, and this is another reason why there's two things. So in AK, Uber worked on this, did a fantastic job too with this KIP to introduce tiered storage, into AK, at least the hooks in Apache Kafka. Confluent has a proprietary offering for tiered storage that allows you to offload, some of those log files to a cheaper storage type like S3, which has been, again, engenders you to be able to keep that kind of stuff longer. But there are companies like New York Times has done a number of talks on that. They store every single article that ever has been published in Kafka for all time. Right. And so that's kind of the storage mechanism, under the covers.
And there's some cool like IO things they're able to take advantage of that allow that like sequential like push to the actual disk to be super efficient. But then even on the read side, they do some nice what's the IO channel thing that in Linux that enables you to like write instead of having a buffer from disk to network,
yes,
you
do that.
you just like do a direct like copy from direct IO or whatever
Although
it is. So they get some cool efficiencies
super plug,
around
I would love for us to switch out our socket server to use Netty so we can use IO Uring. Jens is a friend of mine and a lovely human, and awesome. I love him, and I love IO Uring. So there are further improvements we can make. But yes, we take advantage of everything in Linux to make it fast.
So does this work only with Java, or?
Yeah.
Oh, it's Java only.
No, well, the client side. So as a message producer or consumer, they have also. It's just it's a protocol. So there are protocol implementations for everything. But the initial one was Java.
I'm trying to get a native COBOL client. That's my other push, because I think it would be money. We don't have a native COBOL client yet, but you're right. Everything else pretty much besides COBOL.
Okay.
So the actual Kafka server runs as a JVM process,
right?
But
I get that. Okay. But I'm just wondering who can use it.
Anybody. There's reactive Kafka all the way up. There's all kinds. There's Node Kafka. There's and then there's libRD Kafka, which is like the C interface. And there's a lot of clients we have that are built on that. There's also other popular ecosystem open source clients for stuff like Go and that kind of thing.
So this sounds, maybe this is a weird thing to ask, but this sounds like an important enough thing that I could imagine creating a custom version of Linux just to be a Kafka box or whatever. Is that crazy?
No, I don't think that's crazy. What I would say is that people tend to underestimate the power of Kafka running like it does today. So I'll have customers, and it's really adorable, and they'll go, "You don't understand what our throughput is," and then they'll be like, we might need to push 1 million messages a day. And I'm like,
A day?
yeah, I'm like, oh, right.
Oh,
Like, yeah. And so when you get into those really like where that would be money and what you're talking about is when you would get into a really, really low SLA use case. So, when you're talking about something that doesn't need to go in milliseconds, you're talking nanoseconds, right? That's when that type of optimization, would become incredibly powerful for those specific use cases. For the 98% of other use cases, Kafka running as is on a Linux distro is faster than what most people have ever seen.
Okay. No, it's good to know. Well, plus the overhead of doing what I'm talking about would be huge, and so if the benefit isn't,
yeah, and we do custom things. So Confluent has a fully managed offering too in our cloud, right? And we do custom things in that, right? Like, yeah, we're all over that, right? So that's yeah, and there's other stuff, and I actually was talking to Corey Quinn. I went on his podcast a while back, and
nice.
Yeah, and I love Corey. He's hilarious.
Yeah, he's awesome.
And we were chatting,
hilarious.
And one of the things I think that people sometimes understand is, yes, Kafka is this amazing, distributed system, right? But my passion is really in an inventing space. And when that happens, what I've seen in a lot of organizations is there's a huge pain point where this stuff is great. It's like crack. And all of a sudden now we have it everywhere and we don't know what we're doing. And so the idea of also using Kafka, like when we talk about, and I know it's overloaded term, but central nervous system, is that you're all of a sudden now have observability. You're able to build observability on top of that in a centralized fashion. And that to me, when we talk about why should I use this, what's the business value? That's huge. And it's only going to get bigger as more and more and more. I mean, I see people now asking about eventing, and this to my whole thing is I want to get tires is like swag sometime. So like, and factory tours. So like, I want to be able to like tour a tire factory. And we're seeing more and more companies that are like, legacy manufacturing, everybody coming and realizing that to compete in today's world, right, you've got to be more reactive than 24 hours. And that's really driving this push, to come to Kafka.
And that's a reference to like the typical change data capture nightly batch job kind of thing, is like that's the way that because we didn't have a streaming oriented foundation, we instead would run nightly batch jobs that would take all the events from that day and pump them out to all the systems that needed to know about the changes. And that is just a horrible architecture.
It is. I legit have two pages.
It's very imperative.
I have 2 old pagers in here from like on-call rotations. And sometimes I bring them out and I'm like, do you like still carrying these? Right? Yes, no, maybe. Like, no, that's not the way. You can't, you can't do that anymore and be competitive. You really just can't.
Yeah. Yeah. You need your data and you need it now.
Well, it also sounds a little bit like what crypto was supposed to promise, the journaling and the being able to, go back through, which who knows if it works or not.
There's a lot of interesting parallels, I think, between blockchain and Kafka. The biggest difference, I think, is that in the world of Kafka, you don't have untrusted rights. And the whole point of blockchain is to deal with somehow creating a system of trust around untrusted people that have right access. In the world of Kafka, you likely trust all of your producers that the data that they're producing has been authorized to be written.
Yeah, and as much as centralization, has that bad taste, and because people get to do bad things if they're in a patriarchy at the top. It's like, okay, but maybe there are some things that, like, well, what you just said, how do you trust untrusted people writing? It's like, well, that's a what is that?
Unsolvable problem.
Well, no, I mean, I think it's just a logical inconsistency. It's like you're just saying, how do you trust somebody who's untrustworthy?
Right.
Yeah.
You don't.
You can't.
Yeah.
You can't.
In the world of blockchain, you make them pay to actually, like, you have to give up something of physical value, which in the case of most crypto is electricity, is what you give up. And so that's how you introduce incentives for things to be trustworthy.
Do you remember when we used to have all those FTP servers for like MP3s
Yeah.
back in the day, and you had to
Oh,
have that
yeah.
upload capacity before you could download anything.
Oh,
Yeah,
that's right. Yeah, you had to give
you
something to
did
the system.
exactly. That's
Yep.
like played out again.
Yep. Absolutely.
Yeah,
That's
I
interesting, the
downloaded the first
similarities there.
thing that I ever downloaded was Survivor songs. It was the best band ever. Yeah, I love Survivor.
I remember Survivor.
Yeah,
Like old school rock or
absolutely,
something,
man.
huh?
High on You. Come on, that's awesome.
Nice. So, okay, so I want to transition to, I think we've covered a lot of the reasons why Kafka and some of the basics and all that. I want to talk about architectural patterns. So, one of the architectural patterns that I think is world changing is CQRS. So, tell us about CQRS, what it is, and why it's so amazing.
Yeah, so I think, for me, when I look at CQRS, what I see is resolving something that was never going to work in the first place. When and I admittedly, like, my experience in doing anything that was like UI is not in any way, shape, form as deep as it is on back end stuff, but I have dabbled. And I'm like, why can't you just give me what I need? Like, I know how I need to display this. Just give me that. Like, and that
Right.
to me is the heart of what problem, right? CQR solves is basically, it says, hey, look, the way that you want to store your data, the way you want to write it, you don't want to be bound to that in your display, right? How people might want to interact with that data. And that natural decoupling gives you so much more flexibility, speed makes it easier to develop, both, right? So it's basically decoupling the way my data is stored and written from the way I might want to see it presented. That's to me the idea
That's a
behind
good way to put it.
CQRS.
Yeah. So it stands
Sounds
for
logical.
Command Query Responsibility. No, Command Query Responsibility Segregation.
Yes.
No, am I getting that right?
Separation or segregation.
Okay.
One
Separation.
of the two.
Yeah.
I don't remember.
One
Yeah,
of the
that
two.
one's fuzzy.
Yeah.
Either one works.
Yeah. So separating out the command, which is the way that you write the data, from the query, which is the way you want to view the data, which is exactly what you said. So that's the CQRS architectural pattern, and Kafka is a wonderful foundation for CQRS because you've got a great way to store the commands. What is not in base Kafka is the way to then create those queries, but then we get into Kafka streams and KSQLDB,
which is
right?
why I brought up what's my favorite thing about KSQLDB, right? It's server-side filtering, right? Yep. But Kafka streams, and that is what makes it so powerful. So I fought really hard to get Kafka in our org. And then I was like, I won, and I was like, yes. And I was in my closet, and I remember going, well, crap, now what do I do with it? Uh-oh. What have I done, right? And so then I did my research, and I found Kafka streams. And Kafka streams, the thing I love about it most is, unlike other, when we look at other stream processing systems, right, like Flink, right, or Spark, where you have to have an entire infrastructure to support, Flink and Spark, Kafka streams is just a jar file. And it has a fluent DSL, which is, I love it. It's like, this was like, to me, like the only way that makes Java fun. I was like, wow, I can get on board with this. And Kafka streams is best when you use it to read from a Kafka topic. You do something, that something can be amazing, or it can be something as easy as a filter, let's say, and then you produce it back to a Kafka topic, right? So it's kind of an intermediary. Now, we also have vanilla consumers where you can consume directly from Kafka, right? Do something with it, and then say, I'm going to put it somewhere else. There's also, and we haven't talked about this yet, there's the connect, infrastructure. And that connect is like, a very low code way you deploy a configuration. There's like hundreds and hundreds of connectors for every system that you could think of, right? If you need to ship data out. But where CQRS comes in is basically, now, let's say that I need this data to look a certain way, and maybe you need it to look another way, or you need it to look another way, right? I can spin up a Kafka Streams application, or, and then modify that data, get it in the precise way I want it to look, right? And it's no extra work on the initial data stream, right? No matter how many people grab that data, it's only stored once, and it's the same for everyone. And that's the efficiency that makes me happy in Kafka, right? And then KSQLDB is even a step further towards what we would traditionally think about when we think about the query part of CQRS, because you can create a K-table review and then have an external client come in and get hooks on that, right? Have a long-lived connection that feeds it updates based on a customized view. So that's how Kafka, plays in.
So let me ask a more basic question. When you're talking about this, you're saying, okay, what say I'm a web
Mm-hmm.
client and I want to display some data, and I'm able to then go back and say, here's the data I want, and it just gives me the data I want.
Can
Well, that's
materialize that
kind of
view.
idiotically obvious, right?
Yeah, so
Okay.
I think a actual use case, back to your like address change one, would be an interesting simple one to start with. So if we imagine a system where people are changing their addresses, we are going to store in Kafka every change to that address. And yeah, we could do some compaction, whatever, if we wanted to. But let's just imagine that Kafka is storing user A changed their address, user A changed their address again.
Mm-hmm.
So that is the stream of events that we have. But there's a lot of systems that they don't care about the actual stream. They just want to know what is user A's address right now. And so that's where we get to the ability to then query the materialized view of how have all these stream events gotten us to a specific state that we're in now.
Yeah.
And then there's a whole other part of it, which you mentioned with like Kafka streams, which is, what if we want to take the stream of address change events and do some transformation on them before we then get to that materialized view? Like, I don't know, we want to validate that the address is a valid address or something like that, and if it's not, do something.
Right, or maybe enrich it with a customer name. Maybe we need the name and it's only an ID, right? Like all those things that we need to, build, that non-normalized, kind of like, view of a customer. Absolutely.
Yeah. So I think one of the challenges with CQRS is that the programming model is harder than just a static database table. Like there's more that you have to think about when you move to that architectural pattern. Whereas the simplicity of the database table is nice because there's all sorts of things you don't have to think about. You don't have to think about producer right guarantees and consumer partitioning, and there's just all these pieces that the database table has this nice simple design because you've lost all sorts of
Right. I would say it's
capabilities.
boring, but that's the way my brain works. And I think you're right. There's a large sect of the population where it's a totally new way of thinking, right? And that's kind of where we come in. So part of my job is to help people with that transition and to make sure they're set up for success. So they don't hit all those hard edge cases. They don't have to figure it out for themselves because we already know the best practices. We already know how to do this successfully. But if you're going it alone, I mean, I remember when I did this, I ruined my stomach. I had like 18 Coke cans, and not the small ones, like the pounders. You know what I mean? Yeah,
God.
I'm not kidding you. And I was like, like I was in like pajamas, like my glasses, and I was like, oh, all right, okay. Like, like up here for hours. And I don't want anyone else to have to go through that because sugar will ruin your stomach. Like it will. You cannot ingest that much sugar and have it not impact you. So don't do that. Don't do what I did.
So the way you're talking about it reminds me of immutable data structures in functional programming.
Does it?
It does, I mean, at least, but my brain has been immersed in all that stuff, so I'm not sure if I'm thinking about it correctly.
Well, I mean, I would say you are. I mean, Kafka by its very nature, and that's why I say the other way is boring for me, right? Because I have a functional brain. So people who are who are just driven those functional brains, they see this and they go like, hello. And it's really, kind of bringing other people along who have spent a lot of time in non-functional. That's their comfort zone. That's where they are. And to kind of say, look, not only am I going to, try to help you with this? And we do this in a community fashion too, right? So, Confluent runs a ton of great meetups. They're free. Come join. We do eventing things. We do blog articles. We have an entire pattern repo now for eventing patterns and best practices. It's free, developer.confluent.io, and lists out some like routing slip patterns, like claim check pattern, all the ways you accommodate this way of thinking for how you're currently done. Because as you said, right, that's what makes the database so easy partially is because we figured out how to do that. People know how to do that. So helping people figure out how to do this efficiently, I think is part of our goal.
I think in what you're identifying too, Bruce, is that there is a similarity in thinking about the way that we traditionally, maybe not traditionally, it's not the right way to do it. Mutable objects in object-oriented programming are very similar to mutating a database table.
Exactly.
And now in the functional world, we look at both of those things and we're like, ew, like,
how gross
ugh,
is that, right?
like, yeah, exactly. And so Kafka being this like immutable stream of events that you can listen to and perform transformation functions on, where the
But you
output of the
can't modify.
transformation is just a new stream, but you
Mm-hmm.
can't modify. All of a sudden you're
Mm-hmm.
like, oh God, this, yeah, exactly what Anna said. Like, this fits with how I think about the world and how the world should work.
Yeah, I'm going through that transformation now, and one of the things that I'm really seeing is, oh, the ideas of behind encapsulation sounded good, but in practice, it's like, oh, so we got the data, and then we surround it by these methods, and every method has to make sure that it doesn't put the data into a bad state, and so just do that. And it's like, yeah, that hasn't really worked out so well. So maybe we should just go, all right, how about if nobody can change the data ever? Oh, then I don't need all of those methods attached to the object. I can just make them separate functions. And then I also don't need to worry about whether I put the object into a bad state.
Right.
Oh, okay,
And
this
then
is
you don't have to
simple.
worry about concurrency
Yeah.
and how concurrency is going
Well,
to screw all
Yeah.
this up.
sure, all of that stuff happens, flows out of that. But it's like, I don't know why it took me so long to see it. I think it's just because we presented, oh, encapsulation, this is so much better than what we've been doing before. You know, it's kind of like capitalism. It's like, well, it's better than having monarchy, so it must be the best thing ever, and we should never change it. And it's like the same with objects. It's like, oh, well, this is an improvement over what we did before, but then we go, yeah, but we need to move forward from that. Maybe it did help, but it also looks like a rabbit hole, that a dead end. And the thing is, we never pulled it off. That's the thing, we never pulled encapsulation off.
We just always, I think, hit the places where it stopped working.
Mm-hmm.
And yeah, I guess my pitch is that Kafka gives us the foundation where, yeah, there's some things that are harder about it, but it gives us the foundation that allows us to build almost anything on top of when it comes to data. And we
Well,
don't
and I'm
run into
wondering about
those
the
like
harder
places where it
part.
falls apart.
Is it harder, or is it just we're not, we've been trained to think one way,
Yeah.
and
That
so
and that I think
it's
that counts as hard. So having to change your mindset is really hard.
oh yeah.
They're technically hard, right? Not really. You can spin it
Hmm.
up in 2 seconds. Mind shift hard for a lot of
Hmm.
people. It is, but it's worth it. It's absolutely worth it. Like, come on the functional train. You'll love
Right.
it here. We got donuts, right? Free beer and sherry.
Yeah, although I
And
I
Sherry.
have been, I mean, it's like I've been studying all sorts of functional writings and documentation, and virtually everybody is one of those where it's intuitive.
Yeah.
At some point it becomes intuitive, and then they just start throwing stuff out at the reader as if, well, of course you understand this. They totally miss what one of the best examples of this was the guy who wrote the JavaScript book, JavaScript: The
Oh,
Good
Doug
Parts.
Crawford.
Doug Crawford, he has a presentation where he talks about the curse of the monad, and he goes, so here's the problem. You learn the monad, and then it becomes obvious to you, and then you treat it. And then he says, I'm going to not do that this time. And then immediately becomes incomprehensible,
Right.
and it's like, I don't know if you were trying to demonstrate the curse of the monad or if you really thought you were explaining it clearly. And I just keep seeing this over and over and over again with functional programming descriptions.
Right. So I'm famous for my horrible analogies. That's like, because I always
Give us an example.
Well, I've compared like Linger MS to toilet paper. Right. Again, like I compare eventing to Giardia. I compared actually multi-zone resiliency in Kafka to my husband being drunk, helping me hold up a curtain rod, because I think your point is so apt. You can't get people on board unless you explain it in terms they understand. And if your brain doesn't naturally take to this stuff, you got to find common ground, right? And so I think that's very important in what we do. So, for example, I did a Kafka Streams presentation called called a Kafka Streams Adventure: Choose Your Own Topology. Right? Remember, like those Choose Your Own Adventure books? Like,
Yep.
turn to page 23. And so at the end, I built like this flow chart of your choices. But when we went through it, it was an example where you're trying to catch somebody who's taken too long of a coffee break, right? And screwing your production line, right? So like a real life example, and then showed, how easy this is to do in Kafka Streams. What are our considerations here, right? And I think we need more of that. We need more of things that people can kind of resonate with, because we want everybody to have these benefits. We don't want people to continue to, I sometimes I feel bad because I know, I worked at SAS, which, I'll be diplomatic, has been around for a long time. And
There you go.
and so you see where people go through a transition with all this technical debt built up, and they can't get out from underneath it, and they can't, and be able to introduce them to something like this and make them, basically like their jobs again, is a big part of why I like my job. But to do that, you have to speak the right language. You can't just expect people to pick up on this. I agree 100%.
Yeah, this is, I'm reminded of, I don't know who brought this up, but the carpet bombing consulting approach, where somebody comes in and they say, okay, you're doing it wrong. Here's the right way to do it. Okay, see you later. And then, of course, it has no effect, versus going in and saying, okay, where are you right now? What can you acquire? What changes can you make? And that's harder, of course, but that's to me what the value of a real consultant is.
Yeah. And I think that's very, very apt as well. So like what I do is, and I, again, my full title is incredibly long. I'm really proud of it because it's the longest title, I think, at Counselor.
Okay. What's your
I
title?
am a customer success technical architect. And it's the abbreviation siesta. So that's why I liked it. Because we like to say we help you take a nap, right? So you don't have to worry about production. But that's something we do. So like I am with the same accounts, right? And I do lots of other things as well. But my primary focus is to be with these accounts, right? And the first thing I look at is, what are we working with here, right? What kind of shop are you? What kind of developers do you have? And then we find a success plan that works with what you got. Because no one wants to live with a science experiment for 2 years. Like, that's not showing value. We want to work with what you got. So I think, that's a good point too, is figuring out what can we do that is right, best practices with what, the skills that the people that work there have, with the, the time they have, the priorities and all that kind of stuff.
Can I make a little side observation here about the terminology there? You know how human resources are now just called resources? I mean, first of all, they were called human resources, but now they're just called resources.
Is this just preparing us for the robots becoming resources in these systems too?
When you refer to customers as accounts, think about what that means.
Yeah, I guess
that means
true.
The focus is on the money that
we're
getting
I don't get paid on
you.
commission. I don't care how much they buy.
I know you don't,
but other
you're
people
forced
do.
to use that terminology.
That's true. It should be like Disney, where everyone's a guest, not a customer, right?
Which is full of irony, but
it's a good call out.
Yeah. Anyway, go ahead.
The metaphors give us a frame that we see things through. So yeah, sometimes we need to adjust those metaphors. And then sometimes the metaphors, this is interesting because as you were talking about the metaphors you use to explain Kafka, I was thinking about metaphors that then lose their original meaning, like the save icon being the like floppy disk, and how kids, obviously they've never seen a real floppy disk in their lives, but it still is the icon that for most people now has no actual correlation to reality.
Toilet paper is pretty solid, though, I thought. Like, I don't think that's going away.
That metaphor is not going away.
I mean, unless everyone buys bidets. Like, that was a thing during the pandemic, right?
Right. Yeah, we couldn't get toilet paper. So
is that better? I mean, I'd want to know whether that is using more or less resources than toilet paper.
That's true.
A bidet, there's water issues, and until we solve that problem.
Yeah.
Yeah, maybe
Yeah.
it's not better. It's better experience, but anyway.
Okay, so back to architecture real quick.
Yeah.
What's the difference between event sourcing and CQRS?
Right. So everything, like they're not the same thing at all, right? I mean,
Yeah.
like CQRS is a way that you interact with data, right? And then event sourcing is a way that you basically, I love, like Martin Fowler had this definition, this best definition, because it just cuts to the chase, right? If you can blow away your current state and rebuild it back from whatever your event store is, you're event sourcing. If you can't, you're not. Cut and dry, right? But the thing about, when you look at like, CQRS, that has nothing to do with it, right? You can CQRS in a database, right? Which is clearly, not event source. So there are two different things. And I would say, and I always say there's some people who get, a little frustrated with me. I mean, maybe that's why I don't get invited on certain calls anymore. But they ask, like, what's the number one, thing you say if somebody asks you about event sourcing? I ask them, are you sure you want to event source? Is it worth it? Because 99% of the time it's not. Like event sourcing and eventing are not synonymous at all in any way, shape, or form. And I really, my thing is eventing is for everybody. So, event sourcing, there are some use cases where event sourcing gives you enough benefit to make it worth it to do what you need to do. But there are so many other ones where something as simple as event notification. So I'm just going to tell you an address change. I'm not even going to tell you whose. I'm not going to tell you anything. But I used to have to wait 24 hours to know that. Now I know now, and maybe I go check, right? There's so much value in simple eventing use cases.
Yeah.
So event sourcing would be, I want to know when all of these changes happened, the sequence that they're happening, that they happened.
So event sourcing,
and then from that, I'll build the data that I want. And you're saying, well, most of the time you don't need to do that. You just want the data. You don't want the whole, background
right, and
of how it got that
absolutely.
way.
And sometimes you don't need to store every single individual change for all time, right? Maybe you only want to store the last 7 days, right? And there's other things besides storing those changes. There's like separate. So I always call it the argument of the arbitrator, right? In a database, you have a built-in arbitrator, right? So they have, opportunistic, locking commits, right? So if you were trying to do that in Kafka, right, you would have to build the arbitrator. So there's a big thing on Twitter, and it cracks me up all the time. So like sometimes me and Gunnar, who works on Devisium, we kind of giggle about it, right? Like if you want to piss people off, just like put hashtag DDD and hashtag event sourcing and then mention Kafka.
Nice.
Right. But I think what the point is of the people who kind of come out against that is, one, I don't mind this. I think anytime anyone conflates eventing with event sourcing, it's an opportunity to engage and talk to that person, not an opportunity to make them look dumb. Because come on now, like nobody knows everything. Get over yourself, right? And then the second thing I think their point is, and just because someone perhaps is engaging in a what I would call constructive fashion, doesn't mean they don't have a point. They might have a point. And their point is, I think, in the Kafka ecosystem, right? It's not an out of the box events. There's no arbitrator, right? In vanilla basic Kafka. So if you're going to do event sourcing, you have to build the arbitrator. Now that might be a Kafka Streams application, right? That's going to sit there and make sure that anything, that that opportunistic commit is happening, right, properly. It's the one that's going to reorder, right? It's the one that's going to use epochs. It's the one that's going to know. But you have to build that, right? And I think that's kind of where that comes in Kafka when we talk about event sourcing.
So let me make sure I'm clear on this. Eventing is how you capture all the information.
Yeah, I would say.
Whereas event sourcing is how I'm pulling the information
It's
out
how you're
of
storing
this.
it, right? It's so if I have a
Wait.
yeah.
Event sourcing is how you're storing
Yes,
it?
to me, absolutely. Even though it's sourcing, doesn't sound like it, but it is, right? Yeah.
It's bad terminology.
It is. And that's why I don't get mad when people confuse it either, because it's not like it, we could have a better name for it, because basically what it is my entire picture of a customer, it's stored as the events of that entire customer's life cycle. Like I could back from day one. That's how it's stored. My buildup of the aggregate is based on events. It's the same idea with your bank. That's the classic example is your bank account, right? Your bank account balance is stored as a series of credits and debits, right? Right. I mean, that's all it is a running series of that's then, map reduced down to whatever your, current bank balance is.
Balances, yeah.
Mm-hmm.
Yeah.
Okay, so
So is that example event sourcing then?
Yeah, bank balances? Yes. Yeah.
Yeah.
um, so I'm still not clear. Eventing is the general idea of looking at a system in terms of the events that happen, and event sourcing is how you store those events in your system.
So here's how I like to describe it, right? Well, let's look at and I always use customers because they're an easy example, right? So I have a domain. That domain is customer, right? There's a command based, which would be update this customer. That's like a command base. I go update it. If you're doing eventing, then eventing is this customer was updated. I'm gonna anything that happens, and it always should be past tense, right? So I'm going to tell you about what happened, right, as a stream of events to describe, and anyone who's interested in the life cycle of this customer, I'm going to tell you about it in a stream of events, right? That's kind of and that's how you're going to get information about this aggregate. It's a kind of a descriptor. How I store that customer, who cares, right? That's separate from me being able to describe what happens to that aggregate with events.
So
The one thing that comes up there is, how do you decide what a total event is?
Ah.
I mean, if you're saying, "Oh, this thing happened,"
Mm-hmm. Yes.
how do you?
Oh, I have a great
Yeah.
plan for this, right?
Okay.
So that comes into event storming, right? And event storming, if you guys heard it, maybe for anyone listening to this who hasn't, event storming is a process where you sit down with, LOBs, with businesses. It's very, very homey to the DDD, people. And you kind of build these aggregates, right? What do we care about, right? We care about, customers. Okay, well, what do we care about? Who cares about this? And this is my thing, right? In order, and because I'm wondering if what you're going to is a problem I see frequently, which is bloated aggregates, bloated events, where people shove everything possible, right, into events. And my rule of thumb for this is you need to go look at the value including that information provides. So let's talk about a use case where I'm on a mobile phone and I'm waiting for an update, right, for my flight or something. The human attention span, mine is much less. I don't know what the average is, but mine's even less, right? I'm going to get mad if I have to wait. If there's a piece of information I can include in the actual quote, raw event, the main event, that lets me do that faster, that's worth it. Now, if I got somebody else who runs reports, let's say every 6 hours, and they need to go look up a piece of information, they can go look it up themselves, right? That consumer can consume an event and go, oh, this happened. I need to go get more information so I can do my job. That's not something to me that would need to be included in an event aggregate, right? So that's how I break it down for people when we talk about building, what does that total event look like? It's about finding out what people care about, what information they need to act, and then weighing the value of adding that in.
Right. It seems like, because you have to decide, okay, are we going to look at this in terms of, okay, the sun rose and the sunset, so an event is a day long, versus something is happening now and we got a whole stream of events. The ball is falling, and so we have an event every
You just
fraction of a
teed me
second.
up into Kafka streams. That was beautifully done.
Okay.
Because there are many cases where what I care about is a window or a slice of time over a whole day. And I want to event based off that, like customer interaction on a website, right? I don't want to know every single time they click a button. I want to have a view of their session and have an event of the event is, customer session ended or customer, right? And then I want to know all about that. So what you would do is you would have a raw topic that had every single customer interaction every time they did anything, right? Spin up Kafka streams. We have built-in, tumbling, sliding, hopping windows, right? In just those events. And then you can build that specific, you can build events off of those events, right? That tell you exactly what you need to know.
Okay. But I mean, are you still capturing like the customer pushed this button? I mean, all of those things
that would be like the raw event, but then you want to,
Okay, so you still keep track of all that stuff, but then Stream says, well, what granularity would you like these things in?
That's right.
And
Yeah,
how
a
do you?
time-based stream transform, and that's what
Hmm.
windowing is all about, is giving
Okay.
you those ability to apply time to a stream, and then
Hmm.
your output of that is a new stream
Hmm.
that just has been transformed with the windowing process.
Okay. Okay. So you keep all your raw information and then you turn it into the events that you're interested in.
Absolutely.
But you could also turn it into other events that
Absolutely,
you're
right? Like,
interested
let's say
in. Okay.
yeah, let's say
Okay.
that anytime let's say that you have and regulatory uses for this, like, and also SIM, like, is a great use case for this too. So we have a lot of people who do fraud detection and also, track devices, and they wanna alert when something bad happens. So they ingest a raw stream of events, and then they basically spawn off alerts when that criteria is met, right? So those would be a
Hmm.
new alert event, right? So you can kind of
Hmm.
read these raw ingests of data and then do what you need to do to spawn out new events.
Hmm. Again, this is sounding like very much like functional
Isn't
programming
it
ideas
though?
to me. Hmm. Yeah. Yeah.
Yep, the functional world that we
And
are moving
it's
towards.
easier to think about, I think, this way. So, yeah.
It is a mind shift, but
Hmm.
and I think that it's interesting in the parallels here too with a lot of times the argument against functional programming is like, oh, it's too slow or uses too much memory or too much pressure on the GC or whatever. Kind of similar to the arguments against like durable streams like Kafka is like, oh, that uses too much disk or whatever. And at this point, for both of those, we can respond generally and say like, the resources we have are sufficient for your use case in
Hmm.
98% of the
And
use
again, right, if you
cases.
don't want to do that, just run in our cloud. Then you don't have to worry about it. Yeah.
Hmm.
There you go.
Right. You can throw, if it's a real problem, you can throw hardware and other resources at the problem to
Absolutely.
fix it. And if it's only the 2%, then presumably they have if it's important to them, they have the money to spend on
Absolutely. And that's the thing about, you look at like the use cases that we work with, and those are core critical money costing use cases. And,
it.
and the return on investment is huge, right? For what you're
Hmm.
getting versus waiting 24 hours. Like that customer interaction, especially nowadays, like people don't like to wait. They feel they shouldn't have to. I remember when I first could order pizza online and I didn't have to talk to a human, and I was the happiest person alive. I was like, this is a whole new world, right? And now it is a world. And anytime you have to pick up the phone, people are like, oh, why do I have to call somebody, right? Well, something's got to drive all of that real time interaction. And Kafka, the whole Kafka ecosystem is it's just a natural, to me, elegant fit for it.
So does it come in a way that I don't have to know a lot in order to install it? I mean,
You don't have to know anything
is
if you
there,
use our cloud, which is why, right?
There you go.
Yeah,
They
okay.
also, one of the things I love about Kafka is they also have test containers
yeah.
for it. So actually, Bruce, in our book repo that we're working on, we actually use the Kafka test container to spin up Kafka. So
Oh,
when you run SBT test, you don't even actually have to care where the Kafka comes from because the test container spins it up for you
And
and
something like
manages
Kafka
its life
Streams
cycle.
you can do, and this is one of the things that I love. So there's a company called, I don't know if you're familiar with Backdata. But they are fantastic. They're some of my favorite people in the world. They are incredibly elegant, and they write these, beautiful utility things you want to do in an elegant fashion. One of them is they have a Fluent Kafka Streams test library. And so I always introduce people to that, and that way you don't have to have a Kafka broker. You don't have to have any of that stuff in order to just play around with Kafka Streams. But literally running Kafka, you download a tar and you just go boop. If you want to run it locally, it was never that hard, even without test containers or anything. It was,
Yeah.
so is it hard to get started? No. Is it hard to run it in production successfully? Yes, it's a distributed system, right? I mean, you're getting in.
Yeah. Yeah.
hmm.
It's not your lamp stack. It's
No.
there's more to it.
Yeah, the client end is very easy. I mean, and we the clients are whatever language you're comfortable with, right? There's a client for it, so it's your home. But the actual Kafka broker overhead and managing those, especially large Kafka distributions, when you've got like money on the line, you're going to need to either pay for that expertise in house, or use a fully managed service like Confluent Cloud.
So one of the things my college roommate's son is graduating with a PhD from MIT, and he reached out and he joined the Winter Tech Forum group. And one of the things the thing he and his compatriots are working on is reproducible scientific data. I mean, capturing data, and so that other people can use the data to reproduce results and test results. And this is so once that got stuck in the back of my head, I've been just kind of noticing things, and this sure sounds like a good
I mean,
use
absolutely.
case
Like,
for it.
try doing this without a durable log. Try doing that without a durable log. No
Hmm.
way. And that's what I say about Kafka
Hmm.
streams too, is that with Kafka streams, we use stream time, just like, Flink has watermarks and they have their own thing too. But the deterministic processing of records for something like what you're talking about is paramount. And so,
Well, one of
yeah,
the issues that they have though is vast amounts of data. I mean, like, and you're smiling, so I'm guessing you're going, no problem.
right.
We're good. Okay, so all right. Interesting.
One caveat to that may be that to deal with vast amounts of data in Kafka, you probably are going to have to partition it.
Yeah. Oh,
And so you have
absolutely.
to have something to partition on. And I don't know if there's a use case where you wouldn't have something to partition on, but
There's lots of
it
them
definitely
where you
would
don't,
need to
but they
be
don't care about
partitioned.
order, right? So yeah.
Oh, universal
Yeah,
order.
they don't care about universal order, right? But in Kafka, like you take something like Kafka Streams, right? Kafka Streams naturally inherently builds in order. So what it'll do is when it pulls from a group of partitions, it'll go and it'll pull from the oldest one first. Whatever record was produced before, it'll pull from that and naturally try and reorder things correctly, right? And the way that Kafka Streams works,
It makes an attempt
yeah,
at reordering
yeah,
universally.
absolutely. And the only thing that can, and the nice thing about that is the only thing that can increase time in Kafka Streams is a record. So it's all run on stream time. So what that means is because everything in time is driven by record order, and because Kafka's a durable log, right? Your record order is the same every time. Yay! And so that's how that deterministic processing works, which can be incredibly valuable.
Huh. Nice. Whoa. Well, that was fun.
Yeah.
Very mentally stimulating.
Yeah. I am so convinced on this new stream-oriented world, and thank you for walking us through it, Anna. It's really fun to have you on and chat with you, and definitely look forward to having Sherry with you in person someday. But yeah, anything else before we wrap up? What's your Twitter?
Oh, it's JB Fletch _. I am committed to the underscore.
Mine starts with an underscore.
Yeah.
I should have done. What's the reason for the underscore at the end?
Because there was already a JB Fletch.
Yeah. So in ActionScript, back when I got into Twitter, I was doing ActionScript, and there was a coding convention where class private variables, you prefix an underscore, and it was purely just Python. A convention.
Yeah.
Oh, really? Oh, I didn't know that. Do people in Python still use that convention? Huh. Yep. So when people see my Twitter handle, they think I'm a Python person.
Not necessarily.
I'm going to move my underscore to the end, like Anna has. Yeah. Then I won't be confused.
I don't think it necessarily means that. I think it's just. And of course, not all languages would support leading underscores for identifiers. So
true. Mm-hmm. Well, thank you so much, Anna. That was super fun.
All right. And thank you guys for having me.
Sure.